Do you like statistics?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Statistics is there in every branch of studies. Everywhere, statistics is there. Surface area, volumes, statistics. Can you see? Can you
Yes,
see?
ma'am.
Yes, ma'am. Yes, ma'am.
So, introduction to statistics, tabular representation of data, pictorial representation of data, measures of central tendency. So, let us see introduction to statistics.
Consider some facts about the world we live in today. Rainforests once covered 14% of the Earth's land surface. Now, they cover a mere 6%. In less than 40 years, they could be wiped off the surface of the Earth. According to data collected in 2005, the number of vehicles per kilometer in Mumbai is 591. Over a million people are employed by the Indian railway system. That makes it the largest employer in the world. Facts like these are gathered with the help of a specific branch of mathematics called statistics. In this topic, we will learn about some basic concepts related to statistics. Facts or figures that are collected with a definite purpose are called data. Data is the plural of the Latin word datum. Statistics can be defined in two ways. In the singular sense, it can be defined as the science of collection, presentation, analysis, and interpretation of numerical data. In the plural sense, statistics means numerical facts or observations collected with a definite purpose.
This is what given by Prerana yesterday, the science of collection, presentation, analysis, and interpretation of numerical data.
Data can be classified according to the method in which it is collected. Data, which is collected directly by an investigator with a definite plan or objective in mind, is called primary data. Data which is not collected directly but is obtained from published or unpublished sources is called secondary data. Consider some examples. John measured each tree in his garden and identified the 5 tallest ones. This is an example of primary data collection. Raj consulted the guest history logs of various hotels in Delhi and concluded that most visitors in Delhi are aged between 25 and 40. This is an example of secondary data collection. Data can also be classified according to the manner in which it is represented. The first form of representation is raw data. This type of data is obtained from an original source, but not arranged in any order. For example, marks obtained by 5 students can be written as 84, 35, 68, 94, and 75. Data arranged in a specific order is called arranged data. Marks obtained by 5 students can be arranged in ascending order and written as 35, 68, 75, 84, and 94. Data that is not organized into groups is called ungrouped data. For example, the shoe sizes of 20 people can be represented as shown in the table. When data is placed systematically in groups or categories, it is called grouped data. For example, the shoe sizes of 5 people can be arranged in groups and represented as shown in the table. Data is said to be represented in a tabular form when it is grouped and presented in a table. Some examples of the tabular form are shown.
What is that 24, 29, 30, 35? What are they called?
Class intervals.
Class interval.
Class marks.
Correct. Number of employees, what is that called?
Frequency, ma'am.
Correct.
Data is said to be represented in a pictorial form when it is grouped and presented through a graph or a picture. Some examples of the pictorial form are shown. The difference between the highest and lowest values in data is called the range of the data. For example, in the table shown, the highest value is 95 and the lowest value is 35. Hence, the range of this data is 95 minus 35, which is equal to 60. Now, try these questions and check their answers on the next page.
First one, data obtained from an agency specifying the number of school-going children. Primary or secondary?
Secondary, ma'am.
Secondary, ma'am.
Average height of your family
primary.
members.
Primary, ma'am.
Primary, ma'am.
Raw data, true or false? Raw data is usually presented systematically in groups or categories.
No, ma'am. False.
No, ma'am.
False, ma'am.
Okay. Marks obtained by 3 students are 55, 65, 75. The range is 15.
No,
No,
ma'am.
ma'am. False.
False, ma'am.
False, ma'am.
False, ma'am.
Correct. Vikram asked his classmates to fill a questionnaire. On the basis of this questionnaire, he concluded that most of his classmates were born between 5th July 1989 and 7th September 1989. It can be stated that the method Vikram used to collect data is secondary.
True, ma'am.
Yes, ma'am.
True, ma'am.
True, ma'am.
He collected or what?
Ma'am, he collected, ma'am.
He gave a questionnaire to everybody. Everybody answered. So
Here are the answers for the questions
that
given
is
on the
also
previous
false.
page.
Everything false, false, false.
Raj is the vice president of sales in his office. He needs to present the sales figures of the past 5 years. An effective way to do that would be to present the sales figures in a tabular form. Similarly, if a teacher wants to showcase the performance of the students of her class, she can easily do so by means of a table. Tabular representation of data helps us compare and analyze data. It also helps us provide an overview of large amounts of data. Data presented randomly without any organization is called raw data. For example, the marks of 15 students are listed here. The raw data needs to be arranged in an organized manner so that its salient features can be studied. This is known as presentation of data. For example, the above data can be presented as shown. Data can be classified into 2 types: ungrouped data and grouped data. Grouped data can be further classified into inclusive type and exclusive type.
What is that inclusive, exclusive? How will the group data be? It will have class interval, correct?
Ma'am.
Hello?
No,
So if it is continuous, it is
It is
exclusive. It is
inclusive,
not
ma'am.
inclusive.
Now consider some important terms related to ungrouped data. Numerical data arranged in ascending or descending order is called arrayed data. For example, the marks of students in a class can be presented as shown. The quantity being measured in an experiment is called a variate. In the above example, the marks of the students are variates. The number of times a particular variate occurs in data is called the frequency. For example, the variate 8 appears 3 times, so the frequency of 8 is 3. Consider an example to understand how to convert raw data into ungrouped data. The marks of 15 students are given. To convert this raw data into ungrouped data, we need to follow the following steps. The above data can be written as shown. Here, we have transformed the given raw data into arrayed data. List the variates in the first column. The marks of the students are variates. Enter frequencies of the variates in the second column. Here, the frequency is the number of students. Data is grouped into convenient intervals called class intervals. Here, students' marks are grouped into class intervals. The endpoints of a class interval are called the class limits or class boundaries of the interval. The lowest value of an interval is its lower limit. The highest value of an interval is its upper limit.
Now, is this continuous or not continuous? 1 to 5,
Not
6 to
continuous,
10.
ma'am.
It is not continuous.
We know that grouped data is classified into inclusive type and exclusive type. In the inclusive type, both the upper and lower class limits are included. In the exclusive type, the upper class limits are excluded. Inclusive classes are discontinuous. That is, the upper limit and the lower limit of the succeeding class are not the same. But exclusive classes are continuous, and the upper limit of the class is the same as the lower limit of the succeeding class.
Do you understand the difference?
Yes, ma'am.
Yes, ma'am.
How will you make it continuous? Do you know how to make it continuous? Inclusive type? You have to subtract 0.5 from 1 and add 0.5 to 5. So first one will become 0.5 to 5.5, then 5.5 to 10.5, 10.5 to 15.5, 15.5 to 20.5, and 20.5 to 25.5. To draw the histogram or frequency polygon, we have to convert it to continuous or exclusive type. Okay?
To present grouped data in tabular form, we need to know some important terms. The range is the difference between the maximum and minimum values of data. For example, in the table shown, the range is equal to 25. The size of the class interval is the difference between the true upper and lower limits of a class. For example, in the table shown, the class size is equal to 5. When data is tabulated, each occurrence of an observation is marked as a vertical bar called a tally mark.
Do you know what is the other name for size of the class interval? Size of the class interval. Another name. Anybody? Hello?
Class size.
Yeah. Class size. Another name?
Class
width.
Class width, ma'am.
Correct. Very good. Correct.
To construct a frequency distribution table for grouped data, first we need to calculate the range of the given data. Then we need to decide the size of the class interval. Divide the range by the size of the class interval to obtain the number of classes. Then fill the class intervals in the first column. Next, for every variate, draw a tally mark.
How do you calculate
Count the
range?
number of tally marks for every group and enter the value in the frequency column.
How do you calculate range?
Upper limit minus lower limit.
Upper limit minus lower limit is class size.
Sorry, ma'am, sir.
Highest minus
Highest minus lowest.
Highest value minus lowest value.
yes. Upper limit minus lower limit is class size.
Class size, ma'am.
Range divided by range divided by class size will give you the class interval.
Now we construct the frequency distribution table for a grouped data. The marks of 15 students are shown here. The range of the data is the difference of maximum and minimum observation, which is equal to 24. Let the size of the class interval be 5.
So what should you do now? Next step. What is the next step? You have to divide 24 by 5.
Then, dividing the range with the class size, we get the number of classes to be approximately 5. Let's perform an activity to understand the tabular representation of the given data. The data needs to be grouped into 5 classes, and the size of each class is 5. The occurrence of each variate is denoted by a vertical bar. For example, the first student scored 8 marks. 8 lies in the class interval 6 to 10. So we need to draw a vertical bar as shown. Similarly, 1 lies in the class interval 1 to 5. 8 lies in the interval 6 to 10. 18 lies in the interval 16 to 20, and so on. Note that 5 variates lie in the class interval 16 to 20. In this case, tally marks are to be marked as shown. The sum of the tally marks is the frequency of its respective class interval. Here, the sum of the frequencies is 15, which is equal to the number of students in the class.
What type of class interval is this?
Exclusive.
Inclusive, ma'am.
Exclusive.
Inclusive, ma'am.
Inclusive.
Inclusive.
Correct. Correct.
The marks of 15 students are given. If a student scores 7.5, we can mark a tally mark against the class interval 6 to 10. But if a student scores 5.5, we will have to convert this table into an exclusive type table.
How will you do? How to make it exclusive? Okay. Exclusive. Hello? Can you hear me?
Yes, ma'am. Yes, ma'am.
Can you hear me? How to make it exclusive? Minus 0.5 from 1, add 0.5 to 5. 0.5 to 5.5. 5.5 to 10.5. That will become exclusive.
To convert the inclusive type to the exclusive type frequency distribution, first we need to calculate the difference between the upper class limit of a class and the lower class limit of its succeeding class.
What is the difference?
Then divide the difference by 2. Next, add the
Difference,
value
difference
obtained
is
to
1.
the upper class
1
limit of
divided by
each
2 is
class.
what?
These are known as the true
0.5,
upper
ma'am.
limits.
0.5.
Then
0.5.
subtract
0.5.
the value
So that
obtained
we have,
from each
that
lower
we have to
limit
subtract.
to obtain the true lower limits.
Subtract from lower limit, add to upper limit.
Now consider some examples. Find out the true class limits of the
What is the true class limit here? That is, make it continuous, exclusive. Make it exclusive. Make this exclusive. 16 to 20. 16 to 20 will be
15.5 to 20.5, ma'am.
20.5.
15.5 to 20.5. 21 to 25. 21 to 25. Make it exclusive. 21 to
20.5
25.
to
20.5 to 25.5.
26.5, ma'am.
26 to 30.
26.5 to 35.
Not 26.5. 25.5.
24.
You have to say.
25.5, ma'am.
Yeah. 31 to 35.
30.5 to
30.5.
Correct. 36 to 40.
35.5 to 40.5.
Correct. 35.5 to 40.5.
The bill amounts of 30 houses are given below. Determine the classes if the class size is taken to be 10.
Class size is 10. What is the meaning of class size?
Upper limit minus
Upper
lower
limit.
limit.
Upper limit minus lower limit. Now, what is the smallest number here?
15, ma'am.
No, 14 is there. See?
14, ma'am. 14,
14, ma'am.
Highest.
112.
112. So, first class interval, what do you want to take? 10 to 20 can we take? 10 to 20. Yes? Hello?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100, 100 to 110, 110 to 120.
20.
20.
The number of classes can be calculated by dividing the range by class size, and hence the number of classes is approximately equal to 10. Therefore, the classes in ascending order are listed here.
They have taken it in a different manner. 14 to 24, 24 to 34, 34 to 44, 44 to 54, 54 to 64. How did they get? They started with 14. We started with 10.
Prepare a frequency table for the ungrouped data shown here. Let us arrange the data in ascending order. The arrangement of data in ascending order is shown here.
So what is the frequency for 5?
Ma'am,
3, ma'am. 3, ma'am.
6,
2, ma'am. 2.
2, ma'am.
2.
8, 8,
7,
8,
ma'am.
ma'am. 7, ma'am.
9,
2, ma'am. 2, ma'am.
10,
10,
10,
2, ma'am.
12,
12, 2, ma'am. 13, 2, ma'am. 21, 3, ma'am. 24, 2, ma'am. 24, 2, ma'am.
If you arrange it like this, what is this group called? What is this arrangement of the data called?
Ascending order.
Distribution table, ma'am.
No, this is not distributive table. Table is when you write the data and frequency and tally marks. That is table. This is arrayed data.
The students' marks are
This is
listed
the
in the first
distribution
column.
table.
Write the tally marks in the second column using vertical bars. Let's take another example. The amounts of the water bill received by
Here they want us to have the class size 10. Lowest, what is the lowest? Smallest number. Smallest?
14 ma'am. 14 ma'am.
15, ma'am.
14 ma'am.
Highest?
112. 112 ma'am.
112, ma'am.
112 ma'am.
Range?
98 ma'am. 98.
98 by 10?
9.8. It is nearly 10 ma'am.
9.8, ma'am.
14 to 34 like.
the frequency distribution table is
They have
shown
taken
here.
like this.
During a clinical examination of 30 boys, the following pulse rates were recorded. Prepare a frequency table using the class intervals 51 to 55, 56 to 60, and so on of equal width. From the given data, we get the minimum observation as 51 and the maximum observation as 79.
This is exclusive
The
or
range of the
inclusive?
given data is 28.
Inclusive.
Since the class size is 5 and the range is 28,
Inclusive.
so approximately 6 classes can be formed.
How they got
55 is
six?
included in the class interval 51 to 55 and 60 is included in the class interval 56 to 60.
How they got 6? Number of classes. Range divided by
Class size.
Class size.
class size. Class size is 55 minus 51.
4 ma'am.
5 minus
4, ma'am.
4.
4,
4. 28 by 4. Not, yeah, 28 by 4.
7, ma'am.
6 ma'am.
6 ma'am.
7.
7
No,
ma'am.
28 by
7 ma'am.
7.
Then why they have written 6 there?
Approximately.
The frequency distribution table is shown here. Now, try these questions and
Answer this. What is the lower limit of the class interval 30 to 39?
30 ma'am. 30
30
ma'am.
ma'am.
Range. Second question, range.
75 ma'am.
Correct. How will you
75,
convert
ma'am.
20 to 29, 30 to 39, 40 to 49, 50 to 59 as continuous? Continuous is exclusive.
19.5 to 29.5.
29.5 to
39.5
39.5.
to 39.5.
39.5 to 49.5. 49.5 to 59.5.
Correct. Form a frequency distribution table for the scores of 10 teams in a quiz competition. This is what data is this? Raw data or group data?
Raw data ma'am.
Data, ma'am.
Raw data. Lowest is 18. What is the frequency of 18?
1 ma'am.
1 ma'am.
Correct. Next number is 20. Frequency is 1.
That is also 1.
1, ma'am.
21,
2 ma'am.
2,
2
ma'am.
ma'am.
22,
2 ma'am.
23,
3 ma'am.
3 ma'am.
3, ma'am.
24.
1
1,
ma'am.
ma'am.
1 ma'am. 1 ma'am.
1 ma'am.
Correct. Construct a frequency table starting from the class 25 to 30, exclusive. Exclusive type means 25 to 30. Next number, next class will be
30 to 35.
35.
35.
30 to 35. Then 35 to
40.
40.
40.
40. 40 to
45.
45.
45 to
50.
50.
then you put the tally marks and then write the draw table.
Here are the answers for the questions given on the previous page. Check the answer here. Pictorial representation of data is the depiction of data using pictures and graphs. Pictorial representation makes a lasting impression on the observer, makes it easier to compare large quantities of data, and makes it easier to interpret and derive conclusions from data. Pictorial representation of data is done in the form of graphs. The different types of graphs are bar graph, histogram, and frequency polygon.
When there is a cricket match going on, they will show the graph. Have you seen?
Yes, ma'am. Yes, ma'am.
Cricket match. Which over the wicket has fallen, and they'll give the comparison between the two teams. They will show expected score. Correct? Yes?
Yes, ma'am.
Yes,
Yes, ma'am. Yes,
What is the difference between bar graph and histogram?
In bar graph, there is a space
Histogram, no space in them.
and no space.
Bar graph is for raw data. Histogram is for grouped data. The rectangles are all attached in histogram. In bar graph, they are separate. Correct?
Yes, ma'am.
Yes.
Yes, ma'am.
If you take the midpoints of the histogram and join them, you will get frequency polygon.
The representation of data by a series of bars on a graph is called a bar graph. Points to remember while drawing a bar graph are: bars are in the form of rectangles and are of uniform width. Bars are of equal width and have equal spaces between them. The width of the bars has no significance. The heights of the bars depend upon the frequency and the scale chosen on the y-axis. Let's consider an example to understand the construction of a bar graph. The expenses incurred by a company in different departments are shown in the given table. Draw a bar graph. A graphical representation of a frequency distribution is called a histogram. Points to remember while drawing a histogram are: class limits are represented on the x-axis. Class frequencies are represented on the y-axis. The area of each rectangle should be proportional to its class frequency.
What is the meaning of
The
that?
scale of the x-axis may not be same as that of the y-axis. You can choose a scale according to the type of data.
Area of rectangle is proportional to the class frequency. What is the meaning? What is the meaning of proportional?
Ma'am, equal in ratio.
Equal in ratio.
That means the rectangle, if the frequency is more, the rectangle will be bigger. If the frequency is less, the rectangle area will be smaller. Area of the rectangle will be smaller. How to find area of rectangle?
Length into breadth.
Length into
Breadth. So, if the frequency is more, area will be more. If the frequency is less, the area will be less. That is the meaning of proportional.
Consider an example to understand the construction of a histogram. The given table shows the marks scored by 100 students in an entrance examination. Draw a histogram to represent this information. Draw the x-axis and y-axis. The x-axis represents marks and the y-axis represents the number of students. Now, draw each rectangular bar with width equal to the class size and height equal to the frequency of the corresponding class. The figure obtained is called a histogram. Here, observe that there are no gaps between the bars. Let's understand the construction of a histogram with unequal class intervals with the help of an example. The marks of 24 students are shown in the given table. Draw a histogram for the data.
What is the class size here? 0 to 10?
10.
10, ma'am.
10 to 20?
10, ma'am. 10, ma'am.
20 to 30?
10, ma'am.
10, ma'am.
30 to 60?
30, ma'am. 30, ma'am.
30, ma'am.
60 to 90?
30, ma'am. 30, ma'am. 30, ma'am.
So, when the class size is not equal, we have to do something called as adjusting factor. What?
Adjusting.
Adjusting factor. When do we do that? When the size of the class interval is not the same. Okay? Okay?
Okay, ma'am. Okay, ma'am.
Now you see how to do what you see now.
The class size of the last two class intervals is 30, whereas the minimum class size is 10. Since all the class intervals are not equal in size, the frequencies of the last two class intervals need to be modified with respect to class size 10. The formula to find out the new frequency is the frequency upon the class size multiplied by the minimum class size.
So what is the adjusting factor for 30 to 60? 0 to 10 is 2. 2 divided by 10 multiplied by 10. What do you get? 2 divided by 10 multiplied
2,
by 10.
ma'am.
2. Second one, 3 by 10 into 10.
3, ma'am.
3, ma'am.
4 by 10 into 10.
4, ma'am. 4, ma'am.
4.
4, ma'am.
6 by 30. 6 by 6 by
30,
6
ma'am.
by
By 30 into 10,
10.
ma'am. That is 2, ma'am.
2, ma'am.
2, ma'am.
9 by 9 by
9 by 30
9 by
into 10. 9 by 30 into 10.
3, ma'am.
3, ma'am.
correct.
The adjusted frequencies are shown in the given table. Draw a histogram following the method you have already learned. The figure obtained is a histogram with unequal class intervals.
Here, on the x-axis, we write 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. So 30 to 60 is 2. 60 to 90 is 3.
A graphical device used to understand the shape of a distribution is called a frequency polygon. It is used to compare sets of data. It is used to display cumulative frequency distributions. A frequency polygon can be drawn in two ways, using a histogram and not using a histogram.
What is cumulative frequency? Cumulative frequency. That is, we go on adding all the frequencies one by one. And you can draw with histogram or without the histogram.
To draw a frequency polygon using a histogram, first obtain the frequency distribution and draw a histogram to represent it. Mark the midpoints of the rectangles in the histogram and join them. Now, obtain the midpoints of the class intervals of zero frequency on the x-axis. These class intervals are known as imagined class intervals. Complete the polygon by joining the midpoints of the first and last class intervals with the midpoints of the imagined class intervals.
Why should we join that line to x-axis, beginning from x-axis and ending in x-axis?
To make closed figure, ma'am.
Correct, very good. To make it a closed figure. Only then it will become a polygon. A polygon is a closed figure.
Consider an example to understand the construction of a frequency polygon. The given table shows the frequency distribution of the weights of 30 students in a class. Draw a frequency polygon to represent this data. Draw the x-axis and y-axis. The x-axis.
Why is there a broken line from 0 to 40?
Now it represents that there is no frequency up to 30, ma'am.
Correct. Up to
Up to
40,
40.
not up to
Sorry, ma'am,
40. And also, that is called, what is that broken line called? It's called
Exact
jagged
line.
line. Jagged line, not zigzag, jagged line, or it is called kink.
This represents the weights. Since the data of weight starts from 40 and not 0, we need to mark a kink or a break on the x-axis to signify that the graph is not drawn with a scale beginning from 0. The y-axis represents the number of students. Now, draw each rectangular bar.
Why there is no kink in y-axis? Why? There is no kink in y-axis, that jagged line.
That's
Because the
continuous
difference is
from 0.
the difference is 2. 0 to 2, 2 to 4, 4 to 6. It is continuously 2. So there is no jagged line.
With width equal to the class size and height equal to the frequency of the corresponding class. Mark the midpoints of the upper sides of the adjacent rectangles. Also, mark the midpoints of the classes preceding the first bar and succeeding the last bar. Join all the midpoints. The figure obtained is called a frequency polygon. To draw a frequency polygon without using a histogram, first obtain the frequency distribution. Compute the class marks. Represent the class marks on the x-axis using a suitable scale. Represent frequencies on the y-axis using a suitable scale. Plot the points xi, fi, where xi is the class mark and fi is the corresponding frequency. Obtain the midpoints of the class intervals of 0 frequency, one at the beginning and the other at the end, and join these points.
How do you find the class mark? Class mark is the midpoint. How do you find?
And between upper limit and lower limit, we have to find mid value.
Upper limit
Is
plus lower limit
upper limit
divided by
plus
2.
lower limit divided by 2, ma'am.
Correct.
Consider an example. Draw a frequency polygon of the data shown in the given table without using a histogram. The class mark of a class interval is half the sum of the upper and lower limit. Calculate the class marks of all class intervals. The x-axis represents the allowance and the y-axis represents the number of students. Now, plot ordered pairs where the x-coordinate is the class mark and the y-coordinate is the corresponding frequency. Mark the points obtained as A, B, C, D, E, and F. Join A, B, C, D, E, and F. Mark the midpoints of the classes preceding the first class and succeeding the last class and join them to points A and F respectively. The figure obtained is a frequency polygon.
What is preceding and succeeding?
Ma'am, preceding means before, ma'am. Succeeding means after.
Now try these questions to check your understanding of the topic.
Which class interval has maximum
0 to 10, ma'am.
frequency? 30 to 40? What is the
10,
frequency?
ma'am.
What is the midpoint of 40 to 50?
55,
40
ma'am.
to 50.
45, ma'am.
Oh, 45. What is the class interval that has frequency 25?
20 to 30, ma'am.
20 to 30, ma'am.
20 to 30, ma'am.
Correct.
Try some more questions.
So you can take this question, you try this. Okay?
Okay, ma'am.
Yes, ma'am. Yes, ma'am.
Yes,
And
ma'am.
Yes, ma'am.
this is your homework. This is your homework question. Okay? Will you try?
Yes,
Yes, ma'am.
Okay, then bye, children.